Hello everyone, welcome back to another video. And first things first, if you notice anything different about the video, noticeably audio and visual quality, I'm trying something new because this video is not recorded on my smartphone, which is what I usually use. This is being recorded by my Insta360 Go 3S, which is not meant for stuff like this. It's not meant to show things like up close. It's pretty close to the desk right now. It's actually zoomed in 4K mode. But I just wanted to know if the camera can do this. So yeah, if the quality is bad, like really bad, I will never do this again, and we will go back to business as usual with the next video. But I just want to test it, maybe it doesn't make too much of a difference to me. Maybe people in the comments will say what they prefer. Like, just say what you want, what you like, what you don't like. I'm assuming this video is not going to be that great, because, like, it's an action cam. It's not meant for indoor use or showing things up close, but it has a really nice sensor and a really nice wide-angle lens, so, anyway, the video is about this graphics card. So, I got this in together with some other GPUs. I've already shot a video about the HD7950 from Sapphire I got, and this is yet another Sapphire card. This is an HD5870 VaporX. So this is my second 5870, and the first one that ever worked. So quite a while ago, I bought an HD5870 with, funnily enough, pretty much the exact same PCB, despite that being an XFX card. And I still don't know what exactly happened to that card. I bought it as working, but when it showed up, it was completely shorted out. Like, all the major power rails were shorted out. And before I noticed that, I tried turning it on and the core literally shattered and burned my finger. So, yeah, I'm assuming, like, maybe in shipping, the core cracked because it had a big custom heatsink on it. That may have, maybe the package got dropped or something in shipping and that cracked the core. So I never ran that card. I did end up cutting it in half to turn it into an e-power, and even that didn't work because for some reason the VRM won't turn on, despite the controller having like all the enable stuff. But yeah, enough about that old card. This one actually works, and it's also a rather nice card. So this is a VaporX card from Sapphire. So this has a rather nice heatsink, even though it's just a single fan. Like, it's a 5870, they don't draw that much power, but VaporX means that this cooler has a vapor chamber in it. And it is pretty decent at cooling. Like, this is even not super clean, there's a bit of dust in here, and in pre-testing, this card was both pretty silent and pretty cool, so it is a pretty decent heatsink. But what I want to do in this video is take a closer look at what's under the heatsink. I already know what VRM to expect here because, funnily enough, a lot of HD5870s use the same PCB, despite being from different vendors, because it's a similar thing as with HD7000 cards, where there's a reference PCB that you get when you buy an AMD blower card, but there's also a different reference PCB that a lot of the cheaper models that don't use blowers use, and it's the same deal with this card. Despite this being a VaporX card, it still uses that same VRM, probably because 5870s don't need anything better. But yeah, it has the same VRM as that XFX card. What I don't know is what memory chips are on here, and if they did anything else to customize the PCB, like using more special capacitors or stuff like that. And I also want to see what the cooler looks like from the other side. I'm actually not sure if they changed the display outs. I don't remember what the XFX card had. Because, like, Sapphire did this with the HD7000 cards, that they have this display out, despite the default one being, like, 2 DVIs, an HDMI, and 2 mini display ports. They swapped the 2 minis out for full size. So, yeah. So I want to take a look at what memory chips we have on here. I know they are Hynix because GPUZ told me. I have no idea what Hynix they are. This is a 1 GB card, so this should be 1 gigabit. No, not MFR, Hynix. I'm assuming it's MFR, but it might also be AFR. So that's what I want to figure out. Sadly, it's not Samsung chips like I had on the other 5870, so I Still don't get to test Samsung chips on Radeon cards. But yeah, let's stop rambling and let's actually start taking the thing apart. So yeah, you can tell the PCB is the same because you can like this is exactly the same, just blue, and also the same controller. So let's just take a look at it. Let's just take the cooler off. I haven't taken this off before. I did pre-test the card to make sure it works. So I don't know if the person I bought this from ever took it apart. I guess we'll see from the thermal paste application if it looks like factory or if it looks custom. Oh, they have these I like this kind of heatsink where like they have these little inserts that go into the holes in the graphics card, which really helps it align. And this thing has some pretty sticky thermal pads. Yeah, because these two are... This is a standalone heatsink, so this is just being held on by the thermal pads. Oh, I don't want to break it. Why is it holding on so strongly? Oh. Oh, this looks like it was taken apart before, judging by the thermal pads. Actually... Like, the thermal paste looks pretty factory. Like, this looks a bit too good to be done by a human. Then again, you can kind of see... you can kind of see an imprint of, like, something else that was once around it, maybe? So maybe this person I bought it from is just really good at applying thermal paste. And I guess if this is visible or not is also, like, something to test the camera with. Because I know you can't see this on the smartphone. I don't know if you can see it on the Insta360. But yeah, so we have the vapor chamber here. You can kind of tell it is one because of, like, you see how it, like, you can see the edges of the chamber, and I guess the fill port is, like, here. But yeah, looks pretty decent. We have, unfortunately, the very sticky thermal pads. And this middle one being torn kind of tells me this was taken apart before. So I'm gonna carefully look what's under it to not break it. Is there like one point where it doesn't stick super hard to stuff? Gonna very careful. These are super sticky. Oh, it's AFR. You can just about see that it's AFR. Like, okay, the Insta360 won't be able to see this, I'm pretty sure. But it is AFR. I can just about make it out. So, is this actually not MFR like I expected? That's a decent surprise. Okay, let's take the VRM heatsink off, which is a pretty nice VRM heatsink, actually. The XFX card did not have that. It had... Actually, I think it came with, like, heatsinks thermal taped on, because it had a custom aftermarket heatsink, and I don't know why they always go with thermal tape on those. Oh, this one doesn't want to come off. Yeah, this has a different thermal pad. Yeah, this is exactly what I expected. So, the VRM on this card is... It's kind of nothing special. Like, it's a 5870. These things don't pull a lot of power. And so they don't have very fancy VRMs. I'm also looking for something to clean off the die. Be right back. Before we continue, I'd like to thank my sponsor, PCBWay. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today. So yeah, these cards don't have very fancy VRMs. Like, even the blower reference card, that one has a Volterra VRM with the, like, weird super long inductors where, like, it's like one inductor for all the phases. It's like, it has, like, multiple cores in it, and then the material around it is, like, shared or something. Okay, that's the core. 1034. So as far as I know, this is the production date. So this is 2010, week 34, made in Taiwan. Shows ATI because this is from when before they were acquired by AMD. Okay, and yeah, like VRM wise, this looks exactly like the XFX card. So we have a 4-phase V-core, single-phase memory, single-phase VDDCI. Sapphire does use their like funny finned inductors, but I'm assuming otherwise they are completely identical to what everyone else uses. And yeah, so we have this 4-phase V-core with these massive Renesas diarmoses. Yeah, so these are 40 amp. And the funny thing is, if you have good enough cooling, you can actually push 40 amps through these. Like, it's normal with the diarmoses and power stages that they have a rating that's completely unrealistic to achieve because they would, like the thing is that they would generate so much heat that they would just explode. Like, you would have to, like, I don't know what you would need to cool them because water cooling isn't strong enough. So yeah, like you can't actually push 120 amps through it. Sorry. Something in my throat. Yeah. You can actually push 120 amps through a 120 amp power stage. You can maybe do it for a short while, but it will generate so much heat if you do that long term that like it's not gonna, like, it's gonna overheat and then the rating goes down. With these, they are also pretty inefficient if you push 40 amps through these. As far as I know, like if I remember correctly from watching Bulldoze's video about pretty much this exact card, he has a toxic, so this is like 2 GB, but same VRM. Apparently these generate 11 watts of heat per diarmos at 40 amps. So yeah, that's 44 watts that this thing is gonna have to cool, which you're gonna need quite a lot of airflow at that point. But these are also massive, so these have huge surface area, which not just means that heat sinks are pretty effective on these, it also means that they are just really good at heat sinking heat into the PCB. Like, a lot of people don't seem to think about this, but PCBs are like half copper, and copper is pretty good at conducting heat, so like the PCB is a heat sink too, and if you have a larger IC, it has a larger solder pad at the bottom. That also makes it rather thermally efficient just through the PCB. So, yeah, with enough cooling, maybe you can actually do 40 amps through each of these. And that would make it, like, not that bad of a VRM. Like, yeah, I don't actually remember what this thing draws. But it has 2 6-pins, so, like, it's not gonna be that much. Like, compared to a card with 2 6-pins that I do know the power draw of, which is a GTX 680, that thing's like 180, maybe 200 watts tops, and then you need to like Voltmod it to go beyond that. And I'm assuming this is like the same, about the same. Probably a little bit less actually, because people did say that these are like pretty tame, and I remember my HD 6850, which is very similar to this, also being rather tame. Like that only had a 3-phase. With like very basic MOSFETs, and it was fine. Like I ran it at like 1.45 volts on that 3-phase. It was fine. So yeah, like this VRM for this card is probably fine actually. It's just that by today's standards, this is like nothing, especially for a flagship card. I mean, I guess technically the 5970 is the flagship card, but that's just 2 of these on one PCB. Yeah. And I assume that's basically everything that I wanted from this. Like, really, I just wanted to take a look at the cooler, which looks pretty nice. Like, we can see the vapor chamber, we have decent cooling for the memory chips, we have only 3 heat pipes, but a decently sized fin stack, and the heat pipes, what are they? Maybe 6mm? They might be 8, actually. Yeah, they might. I think these are thicker than like the usual ones you get, and I think the standard size is like 6mm heat pipes. So these might be. Actually, let's just measure it. How thick are these heat pipes? No, they're 6. They're 6mm. Okay. So these are 6mm heat pipes. But like it looks like a decent fin stack, and like from testing, this is a pretty decent cooler, even with like all the dust stuck in it, and just one fan. So yeah, decent cooler. I did pre-test the card in terms of overclocking as well. I can't really tell if this is good or not, but the core does a gigahertz, and the memory does 1300. I do remember that these are not quite as good at memory overclocking, probably because the memory controller isn't that great on these. And I mean, yeah, because the stock core clock is like 875, and I brought it to a gigahertz, so that's over 100 megahertz overclock. The stock memory clock is 1250, and I brought it to 1300. So it went more than twice as much on core than it did on memory, which is quite untypical. Usually a memory does add like way more clock than your core, because memory is just higher clock than your core. So I'm not going to immediately scream and fault the memory chips for this, though I do remember 1 gigabit AFR to not really be that great of a chip, like on NVIDIA Fermi cards. It's actually like basically the worst chip you can get on NVIDIA Fermi cards. It depends, because there seems to be like two kinds of 1 gigabit AFR, and I don't really know what the difference is, if there's like a speed spec difference between them or like a batch difference. But most of the time, if you get 1 gigabit AFR on Fermi, it does not scale with voltage, and it also just doesn't overclock that well. Yeah, and that's just kind of crap, because like if you increase the voltage on it, it gets worse. It's just like the opposite of what all the other memory chips do. And then there's some cards with the exact same memory chip, also 1 gig AFR, that do scale with voltage. They still don't clock that great, but they do scale with voltage, which makes them like not horrible anymore. So I hope that this has the kind that scales with voltage, because otherwise this would be kind of not great. And I don't feel like transplanting the 8 memory modules from the other 5870 onto this, because I mean I have like properly reflowed memory modules before, and I have replaced memory modules, just not on working cards. So doing it 8 times successfully is a bit of a reach for myself. So yeah, I guess I'm just gonna have to deal with Hynix. And as for the last part of the video, so I thought of something that I want to try, because like, while I think that these videos are interesting, where I like take a look at the card and we look at all the parts on it, I do feel that they are like a bit low effort, especially this one where I like just run a random camera that's not supposed to do this, so the video probably suffers a bit as well. I thought that to add a little bit value to the video, I would attach a Voltmod guide for the card that I look at. So I'm gonna look for the controllers of all the 3 major power rails, and I'm gonna look up their data sheets, and I'm gonna take some macro shots, and I'm gonna put them on my tablet, and I'm gonna tell you exactly what pin you need to solder to, what size potentiometer you need, and all that stuff. So you can at least, you know, take something of note away from this video other than, hey look, VRM. So I'm gonna do that now. I'm gonna look up some data sheets and then tag that onto the end of the video. And yeah, see you then. So, welcome to the Voltmodding guide part of this video. First we're gonna go the vCore controller, of course, and the vCore controller for the card is the UP6213. So this is specifically a 6213A variant, since we have the 4-phase variant. Specifically it's an AJ. And we have the pin out right here, down here. And our feedback pin is number 17. So this is the pin that you're going to connect to for Voltmods on vCore. And let's go over to GIMP and show that. So this is the controller on the board. Specific to note, the dot right here, or also this arrow on the PCB, because that indicates this dot in the datasheet. So you need to make sure the orientation is correct. The orientation of the text on the part is not always the same as the orientation in the pinout diagram. In this case it is, but you need to be aware of that. So feedback pin number 17, on the right side, the fourth pin from the top, that would be this one, and the trace goes out and touches this resistor, and it actually looks like it may go all the way here. I'm not entirely sure. I can see a connection between these two. There may be one here. I'm not too sure. It's not really easy to see these traces, unlike this blue PCB, but you can easily just check this with a multimeter, you know, measure the resistance between the 2 points, and if it's 0 ohms, then they are connected. But I can tell you for a fact that this side of this resistor is where you can connect your Voltmod for feedback. And this works with both kinds of Voltmod. So if you do the traditional kind of Voltmod, where you use a potentiometer, you will connect this to one side of your potentiometer. You leave one no connect, and you connect the other one to ground. So that's the, you know, regular style of Voltmod. And of course you need to measure the resistance on this pin. I haven't measured it for the purpose of this video, because my preferred way of Voltmodding is the other one that I'm going to show, where you don't need to measure the resistance. But yeah, measure the resistance to ground with your multimeter, multiply that by 20, and then use the next biggest potentiometer size that you can find. That way you're gonna make sure that your idle voltage is not gonna be like too high. And of course also remember to turn the resistance to be at maximum between the 2 pins that you use, and not between the 1 pin you don't use and another one, because yeah, if you put all the resistance to that side, you're gonna have no resistance on that side, and you're gonna short feedback to ground, and that's gonna make your VRM potentially not turn on, or potentially output 12 volts, both of which is bad. So yeah, I mean, I shouldn't have to go into this. I did make a very long video explaining all of this stuff. Really, I just want to show the pins, and I'm just assuming you know how to Voltmod, so let's go to version 2. So version 2 is the EVC Voltmod, which is what I prefer, because you don't need an extra potentiometer for that. You just need an EVC, and like all the stuff you solder to the card is just wires, and the EVC is of course replaceable. So again, we use the feedback pin, but instead we connect that to just the EVC. Like it's just the, you know, that's an F. We just connect that to the EVC, and then at the same time we also connect a ground reference to the card, and we connect a VCore. Wonderful, I'm doing this on PC and not the tablet, so I can't write. Yeah, so because for the EVC Voltmod you connect feedback and the output, because how the EVC works is like it simulates a potentiometer by using its onboard DAC. So like pushes extra current into the feedback circuit or drains some current away from it, therefore simulating a potentiometer. And the ground and VCore leads are just for the EVC to be able to, you know, see the output voltage, because yeah, I mean in the interface that there's a voltage readout, so that's what they are for. So yeah, that's how it works. Important bit, use that right there to connect your Voltmod. And if you're doing potentiometers, make sure to measure the resistance and select the right size potentiometer. Then the other 2 VRMs. So our memory and VDDCI VRM are actually controlled by the same thing. It's controlled by a UP6101. And this is one of these wonderful 8-pin ICs. And every single time I look at a datasheet for these, feedback is on pin 6. If it's one of those 8-pin ICs, it's literally always been pin 6 every single time I checked. So this might just be like a standard configuration at this point. You might just not have to look at a datasheet for one of these 8-pin things. I would still make sure, of course, but yeah, it is pin 6 again. Again, look where the dot is in the datasheet, because in this case it does not line up with the text orientation, because this is, you know, how do you call it, vertically, and then on the card it is horizontally, and the text is like this way. So yeah. Anyway, dot is right here. We also have an arrow on the PCB again, so this is pin number 1. And then because the numbering is 1, 2, 3, 4, 5, 6, this is our feedback pin right there. And in this case, I actually recommend that you solder directly to this pin. And the reason why is that, well, you see the size of the SMDs around here. The pin is physically larger, and the pin is also physically more robust than any SMD you could solder to, even if it's an empty pad like this one. Because ripping traces out or ripping SMD components off is way easier than damaging this pin right here, because this is a massive pin compared to the pin size on this. You know, like these are the same size components. You see how small this pin is. You see how massive this pin is. So on these kinds of controllers, I actually always solder to the pin directly. You can of course like use any of this if you want, but I would go with the pin directly. And I'm really sorry about the ambulance. Yeah, so I'd recommend to solder directly to this pin. And yeah, the neat part is that this is true for both memory and VDDCI. This specifically is a picture of the memory VRM controller, because the VDDCI is on the front of the card, and I put the heatsink back on, so I couldn't take a photo. But it's the exact same part I checked before putting the heatsink on, and all you need to do is just look where the dot is, or look where the arrow on the PCB is, and then, you know, go to this pin. And yeah, again, same procedure. If you use a potentiometer, go to this pin, check resistance, select your potentiometer, and then connect to ground. Or with the EVC, just connect this directly to the input on the EVC, and then, you know, also hook up an output sense and a ground. You don't need, like, you only need one ground total. So you, like, the EVC has 3 inputs, you only need 1 ground for all of those. So if you do core, if you already have ground for core, you don't need to add another ground for this. But yeah, so that's the Voltmod guide. Pretty straightforward. Like, there shouldn't be a lot going on. We don't have any fancy stuff of like traces going through PCBs, you know, like going into vias like this. This happens sometimes. We don't have super long traces that we need to keep track of. It's pretty easy to just hook this up. So just be careful while soldering that you don't damage anything around it. Like, I have done this a couple times when I started out. Yeah, I don't want to drag this video out any more than that, but like quick soldering tips, it's like use flux and learn to do it like quickly, and like have a high power soldering iron, because I used to use like a 75 watt cheapish soldering iron, and for these small things this was enough, but for like bigger things it would need a while to heat, and then while you wait for it to heat, bad things happen. Like with the new soldering iron, which I did make a video about, I just tap it and it immediately, you know, liquefies, connects, and then solidifies again. Which is quite nice, because like I really like that soldering iron. It's nice. And yeah, so that's it with the Voltmod guide. I hope these segments make the videos much more informative, because lots of people can look at VRMs and go, oh, yeah, this has so and so many amps, and this is so and so many phases, and this many capacitors. So yeah, so I want to add this extra value to the videos. It's just like, so you can go to other channels to like have someone look at the PCB and go like, I like this, or I don't like this. But I don't think, well, actually Boltzert used to do this. I don't think he does it anymore. He does more, he does more like stuff with like VRM efficiency. But I don't think he does this stuff anymore where like he shows you exactly what to Voltmod things. So I'm gonna start doing this. I'm gonna, you know, have this unique part about my videos to make them worth watching over other people's videos. So I hope this helps, and because the video is probably way longer than I planned for now, I'm going to say goodbye.